Hey there, science fans! Ever wonder about the history of electricity? It's a wild ride. Long ago, people knew about electricity, they just didn't understand it. The ancient Greeks noticed something strange. Rubbing amber, a fossilized tree sap, made it act funny. It attracted things like feathers or hair. The Egyptians also had a shocking secret. They knew about electric fish. These slippery critters could give off a jolt. Imagine their surprise. These early observations sparked curiosity. What was this mysterious force? It took centuries to find out, but these early encounters set the stage. The quest to understand electricity had begun. Stay tuned for more electrifying discoveries. Fast forward to the 1600s. Scientists started studying static electricity. They rubbed different materials together. They saw how objects attracted or repelled each other. They realized something was going on. Could it be a type of fluid? One scientist, William Gilbert, had an idea. He called this mysterious force electricus. It came from the Greek word for amber, electron. That's how electricity got its name. Pretty cool, right? But what was this electricus? Scientists were determined to find out. Little did they know, even bigger discoveries were just around the corner. Let's talk about Benjamin Franklin, one of the most fascinating figures in American history. He was not only a founding father but also a brilliant scientist and inventor. His curiosity knew no bounds. Franklin was particularly obsessed with electricity. In 1752, he conducted one of the most daring experiments of his time. He wanted to prove that lightning was electrical in nature. So he flew a kite during a thunderstorm, a very risky endeavor. The kite had a metal key attached to it, and as the storm raged on, lightning struck the kite. Seriously, don't try this at home. Electricity flowed down the string and gave Franklin a shock. He was incredibly fortunate to survive the ordeal. But his experiment was a groundbreaking success. He demonstrated that lightning was indeed a form of electricity. This was a monumental discovery. It showed that electricity wasn't just a static phenomenon, it could flow and be harnessed. Franklin's work laid the foundation for future scientists and inventors to explore and understand electricity even further. His contributions were pivotal in the development of modern electrical science, paving the way for countless innovations that we benefit from today. Meanwhile, in Italy, another scientist made a groundbreaking discovery that would change the course of science forever. His name was Luigi Galvani, a dedicated and curious scientist. One day, while he was dissecting a frog, something extraordinary happened. Suddenly, the frog's leg twitched unexpectedly. Galvani was shocked and intrigued by this mysterious movement. He soon realized that the twitching was caused by electricity, which could make muscles move even in a dead frog. Another brilliant Italian scientist, Alessandro Volta, heard about Galvani's experiments and was deeply intrigued. Volta decided to build on Galvani's work, conducting his own experiments to understand electricity better. Through his relentless efforts, he invented the first electric battery in 1800, a monumental achievement. This invention was called the voltaic pile, a groundbreaking device in the history of electricity. The voltaic pile was ingeniously made of layers of zinc and copper discs. These discs were separated by cardboard soaked in salt water, creating a chemical reaction that produced electricity. The voltaic pile produced a continuous flow of electricity, a true game changer in the scientific world. For the first time in history, scientists had a reliable and consistent source of electricity to power their experiments. This incredible invention paved the way for countless other discoveries and inventions, revolutionizing the field of electricity and beyond. Section 5. Michael Faraday, the father of electromagnetism. Let's fast forward to the 19th century. Michael Faraday, a British scientist, took center stage. He was fascinated by electricity and magnetism. Faraday discovered that electricity and magnetism were connected. He showed that a moving magnet could create electricity. This discovery led to the invention of the electric generator. Generators use magnets and coils of wire to generate electricity. Faraday's work revolutionized the world. It paved the way for the widespread use of electricity. Thanks to Faraday, we could generate electricity on a larger scale. The world was about to change forever. Section 6. The Electric Revolution, powering the world with light and energy. The 19th century was a time of incredible change. The Industrial Revolution was in full swing. Factories were popping up everywhere. They needed power, and electricity was the answer. Electric motors replaced steam engines. They powered factories, trains, and streetcars. The world was becoming electrified. But there was one problem. How do we get electricity to homes and businesses? The answer was the electric grid. This network of power lines could transport electricity over long distances. The electric revolution was about to begin. Section 7. Thomas Edison, illuminating the world, one light bulb at a time. One name is synonymous with the electric revolution, Thomas Edison. This American inventor changed the world forever. He is best known for inventing the practical incandescent light bulb. Before Edison, people used gas lamps or candles for light. Edison's light bulb was a game changer. It was safer, brighter, and more convenient. Suddenly, people could light their homes and businesses with the flick of a switch. Edison didn't stop there. He also developed the phonograph, the motion picture camera, and many other inventions. He was a true visionary who helped to usher in the modern electric age. Section 8. Nikola Tesla, the visionary genius of alternating current. While Edison was a champion of direct current, or DC, another inventor was busy developing a rival system. Nikola Tesla, a Serbian-American engineer and inventor, believed in the power of alternating current, or AC. AC had a major advantage over DC. It could be transmitted over much longer distances with minimal power loss. Tesla's AC system eventually won out and became the standard for power distribution worldwide. Tesla's contributions to electrical engineering are immeasurable. He developed the AC induction motor, transformers, and many other innovations. He was a true genius who helped to shape the modern world. Section 9. The electric grid, a network of power connecting our lives. The electric grid is a marvel of modern engineering. It's a complex network of power plants, transmission lines, and substations. It delivers electricity to millions of homes and businesses. The grid is powered by a variety of sources, including fossil fuels like coal, oil, and natural gas, nuclear power, and renewable energy sources. The grid is constantly evolving to meet the growing demand for electricity. It's a testament to human ingenuity and collaboration. It shows how much we rely on electricity in our daily lives. Section 10. Renewable energy, harnessing the power of nature for a sustainable future. As we move towards a more sustainable future, renewable energy sources are becoming increasingly important. These sources, such as solar, wind, hydro, geothermal, and biomass, are replenished naturally. They offer a cleaner and more sustainable alternative to fossil fuels. Solar panels convert sunlight into electricity. Wind turbines harness the power of the wind. Hydroelectric dams generate electricity from flowing water. Geothermal power plants tap into the Earth's heat. Biomass power plants burn organic matter to generate electricity. These renewable energy sources are helping to reduce our reliance on fossil fuels and combat climate change. Section 11. The future of electricity, innovations and challenges in a connected world. As we look ahead, the landscape of electricity is rapidly evolving, bringing both opportunities and obstacles that we must navigate. The future of electricity is full of exciting possibilities. From the way we generate power to how we consume it, every aspect is undergoing a transformation. Smart grids are being developed to improve the efficiency and reliability of the electric grid. These advanced systems can manage electricity demand in real time, reducing outages and optimizing energy use. Energy storage technologies such as batteries are becoming more advanced. These innovations are crucial for storing energy from intermittent renewable sources like solar and wind. They allow us to store electricity generated from renewable sources. This stored energy can then be used when the sun isn't shining or the wind isn't blowing, ensuring a steady supply of power. Electric vehicles are becoming increasingly popular. These vehicles not only reduce our reliance on fossil fuels, but also help in cutting down greenhouse gas emissions. They offer a cleaner and more efficient alternative to gasoline-powered cars. With advancements in battery technology, electric vehicles are now able to travel longer distances on a single charge. The world is becoming more and more electrified. From our homes to our workplaces, electricity is the backbone of modern life, powering everything from our gadgets to our transportation systems. We face challenges in meeting the growing demand for electricity, ensuring grid reliability, and transitioning to a more sustainable energy future. Balancing these demands requires innovative solutions and a commitment to sustainability. But with continued innovation and collaboration, we can create a brighter, more sustainable future powered by electricity. By working together, we can overcome the challenges and harness the full potential of new technologies to build a resilient and efficient energy system for generations to come.